Hello everyone, it's Saurav, and today I will be talking about error handling, which is one of the most core concept I think most of the video tutorials on the internet miss today. One thing that I want to make clear before we even start this, that what I'm going to be talking about first is going to be majorly about error handling and all that core concepts that are required, whereas I'll be showing you an example in Express, which is a JavaScript framework. We will be using TypeScript, by the way, not JavaScript itself. But if you are free to follow, if you know this, or if you know Express, if you've been using Express or JavaScript or TypeScript, doesn't really make much of a difference. But if you're using some other frameworks, like if you're using building upon top of C# or maybe some other languages like Java, the concepts are pretty much the same. Only difference would be that you need to check the documentation of the framework that you're using. Now we'll be using Express. It provides you a bit of error handling and the architecture for that, but you need a bit of configuration if you want to make it even more robust. Now, one other thing that you need to know, if you're using something like Nest.js, frameworks that are built on top of Express like Nest.js, the best part of Nest.js is that provides you a sort of pre-formatted error message that you can build, that you can try, and like it's generally what we're going to do, but it provides you that out of the box. So you don't need to worry too much about error handling if you're using something like Nest.js. However, still, knowing the basic key concepts behind this is a pretty good idea. So I would still suggest you to follow along, even if you're using something like Nest.js. All right, so let's get started with the basic part. Now, I have a quote from the book called Clean Code here, and the quote says that error handling is important, but if it obscures logic, it's wrong. Now, what this thing is actually trying to say is generally how error handling works in general. So by that I mean that error handling is a real key concept when it comes to creating backends or creating system programs or anything at all. Now, error handling is something that is done at top level, which simply means that if you're doing error handling, or if you're just simply making an architecture for your application, no matter what sort of application it is, you need to think about it beforehand. It's not like you can just simply go on, start writing code, and things will like come into play automatically. That just won't work when it comes to building up huge applications or huge production applications. Error handling is something that resides at the core when building huge production applications, because if you're not handling errors and exceptions pretty well on your production application, well, 90% of the time that's going to fail horribly bad. Let's think about an authentication flow, or sort of a happy flow. What would you call it? A happy flow of how a user like generally logs in and get access to your application. A happy flow would be that a user comes into the application's main page, heads over to the authentication page, and simply logs in and gets access. Well, this is what the expectations are if you are thinking in relatively simple terms, that the user would simply come up and log in and that's it. However, the reality would be quite different. Like, for example, the user comes into the authentication page, tries to log in, and then there are problems. Like, it could be a case, like it's really not always that the database is down, but it could be a case that the database is down. It might be that the user who's trying to log in simply does not exist. There might be network issues and even more errors. For example, if the user had provided some wrong credentials and something like that. That thing, what you call in the between, that's sitting in the middle, like providing an interface between the user and your backend API or any service, that is where error handling comes into play. And that is where the core idea of error handling resides. Now, why are errors important in the first place? Well, now I'm talking not about errors, but good errors. So for example, if you are creating a API, you are a backend engineer, you're responsible for creating an API, it is up to you to encode errors, serialize them, and send them just in case something fails. And by that I mean that you are writing good errors, because it's the job of a backend engineer to write errors as well. Now, what might be like the good ideas behind writing some good errors? Well, the first thing is that it's much more easier to debug them. Now, if I can tell you that if you are throwing simply an error, like an error occurred, and you are providing zero context of where that error is, what is it about, what just happened, anything at all, then that's a horrible error, because you will have at least a really hard time debugging that error, because you have zero idea where to start. That's why writing good errors is important. Second, the thing we're talking about is explicit development logging and better understanding. Now, if you are in development environment, it is better to log your error and provide stack trace and provide as much explicit information as you can. As long as you're in development environment, that will also make sure that those errors are debuggable and easier to solve. The third core idea about error handling is that it provides you a robust architecture. Now, why does error handling provide a robust architecture? Because if you know that you have handled almost all the errors, you will be at a state of peace of mind that, yeah, something might mess up and that's probably like an edge case, but everything won't break because you have actually handled quite a lot of stuff. Other thing would be better code and architecture predictability. That is something that error handling provides, since you already know, like, okay, if I'm starting from here and I'm going till there, if I'm starting at A and I'm going till Z, there are problems at B, C, or H, or like somewhere in between, but you have already predicted that there might be problems, and these problems are what that can occur. Now, if you already know beforehand that these are the problems that can occur, you can already handle them, and that's where better code and architecture predictability comes in. Now, quick downtime to uptime is more like, for example, if a unhandled exception is thrown at a production level or in a production environment, you'll have much easier time because you know that it won't be this error because that error is already handled. It could be possibly something else, and that's where this code predictability and quick downtime to uptime relates. Reusability is really important because if you have an error class that we're going to be creating soon, if you have something like an object-oriented approach of creating errors, you will have much easier time replicating them and reusing them across your application database. And finally, much cleaner and readable code. After all, we are striving for a readable code. Now, let's think of errors in web development. Think of this as a simple server or an API that you have. That might be a cat controller, let's say. You have 5 routes. The first one is get route, like to simply get all the cats. The second one is to get a cat via its ID. The third one is to create a new cat, update a cat, and then delete a cat. And let's just say that all the things that are requiring authentication are protected by a authentication middleware. Now, let's just say that if any of this messes up, for example, you're getting all the cats and something messes up. For example, let's just say the database is down. Something like that. Rather than sending straight up an error to the front end, what we can do is to commit across and like parse it through a error handling middleware that's going to change the style of the error, and it's going to change how the entire application or the error looks like, and then it's going to forward it to the front end. That's the core idea we're fighting for, and that's where this entire application architecture comes into play. If you have a data, then you simply forward the data and let the front end know that this is the data. And for example, if you're having an error, you generally pass it through a middleware that's going to handle it. The reason it's going to handle it because it's going to make sure that everything or every error that is fired, no matter where from the application, has a definite architecture. Now, why might that be important? Let's say that this route throws an error that's completely a different structure than this one, and this one throws completely different one, and same goes for all of this. Now, this will be a really pain for front-end engineers to handle because that's going to cause issues. Why? Because this route is completely different. So you will have to implement error handling in a completely different way on the front end. And this might be different, so error handling completely different way. This might be different, so again, error handling in different way. And that's a horrible problem. That's a huge problem. The reason for that is that now, for example, if you have an application that have more than 500 endpoints, that's going to be really a lot of pain because you will have to implement 500 ways to handle one error that can occur across every place of your application. So it's better to handle things on the server rather than to delegate them to the front end. And that's where the front end style comes into play. For example, if everything is coming into one structure, if every error is coming in one structure, so the front end will know that I only need to create one component, and I know definitely that this will be the structure of the error. The approach we're going to take is that we're going to create an abstract class that's going to be used as a blueprint or sort of a inheriting skeleton that's going to be inherited by several other errors that are going to have a simple property. And now that abstract class will also have a method called Serialized Error, and that's where our error message comes into play. Our error message will be typically the simple error message that says that error type, and I'll be showing you why this error type is required. It's not always required. I have seen people not do this and some people do that, but it's up to you. I mean, generally it's your requirement. But the main idea is that we're going to have an object inside of which there's going to be an error array, and inside of which we're going to provide all the objects, all the errors that are occurring one at a time, having a message property and a property if required. For example, if you're doing some validation and the username validation failed, it's going to provide a property of username and the message that username validation failed, or username must be longer than 1 character, 2 characters, something like that. So that ends the idea of how this thing is going to work, and let's get going. All right, so right here I have a bare bone Express application. We're using TypeScript, and I have a source folder. Source folder inside of which we have a routes and the index.ts where our index file is. For the package, I have simply created a start script. Let me zoom this in. So for the package, I have simply created a start script that's using tsnode-dev for simply working on TypeScript rather than simply compiling stuff by tsc and then doing all the stuff, but we're simply creating this. Now I can also create a build command, say just tsc, that should do the job. For example, if you want to create a dist folder, and if I do a yarn tsc, that's going to generate a dist folder in which I will have everything predefined. So that's what the core idea about it is. But this tsnode-dev does not need to compile everything out of the box and then put them into dist folder. It's completely up to you how you want to take that. We have Express node and tsnode-dev and TypeScript as developer dependency, and we're using Express as dependency for now. Let's see what will be required furthermore. I am not creating any sort of backend or should I say database connections. So we're storing cats as a simple array. So it's completely up to you how you want to make this, but for the sake of simplicity, I will be storing things like this. Okay, so in index.ts, we are simply making a body parser. We are also setting the cat router or the router to handle everything for the cat endpoints, and we're simply listening for the connections at port 5000. For the cat router itself, we are creating an array of cats. We're giving them an ID to identify them. Then we have name and age property on them. And we're creating a router and exporting it as default. We have a get function which gives you back all the cats. We have a post function which creates a new cat. We have a put function which updates a cat via its ID, and we have a delete function which deletes the cats and delete a particular cat. Now, let's try to think of possible scenarios that could occur. Let's say, for example, when we are creating a new cat, the user doesn't provide a property, for example, the name, the age, and the ID. What's the most possible scenario you could do? One possible thing would be to check it. So they'll say that if name.length, so now this thing right here comes into play that the TypeScript is telling you that the name is of type any, since you can see, so type any. So what I can do here is I can simply provide a thing like that, and I can call it string. I can call it age is sort of a number, and ID is also a number. So now it's going to help me with this. So if I'll say that age.length is equal to, like, for example, is less than, or let's say is less than 2, then we simply say return res dot. Now this is generally what people would do, like res dot status, and I will say 400, and then I'll say dot send, and then I'll send something, things like that. This is where our general response would come into play, and we'll say that, okay, there's some error, and do all this stuff. But is this feasible? The reason is that this is not feasible. And why might that be? Because every single time you're returning this, it's up to the engineer who is working on this. For example, if you're working on that, it's up to you what the error architecture will look like, or what the structure of the error would look like here. That's what we're trying to avoid. So what else we can do? Well, if you head over to Express documentation, you will see that the Express framework provides you something called an error handling middleware. It's the only middleware that exists in Express that takes 4 arguments rather than 3 arguments that's generally provided by Express, called request, response, and next. So what this error architecture does is that if you throw a new error, for example, like this, anywhere in the middle, Express will handle this for you automatically. You don't need to ever worry about it. So let's try to do that. So in here, I'm going to create a new file. So generally you would create inside of utils or something, so I'll just call it middlewares. And inside of middlewares, I'm going to create a global error handler.ts. So let's just import a few things. We need request from Express, we need response, and we also need next function. Now right here, I'm going to create a new middleware, so I'm just going to say const. So I'll keeping it error handler, and like that, and I'm going to say export default error handler. I'm going to save this. Also, I should keep it camel case. Cool. Okay, so as I told you, it takes 4 things. So it does not take like that. It takes rather than, so just in case if you don't know, the middlewares in Express takes in three arguments. They're going to be request, response, and next, like this. However, when we're talking about error handler, it takes 4. So the first one is error itself, like this. Now right here you will see errors because TypeScript is not able to infer the type, so we'll explicitly provide them. We'll say error, it's going to be request, this is going to be response, and final one, this is going to be a next function. Now Express will automatically know that this is a error handling middleware. So just in case, if you want to see how this works, rather than doing this, we'll just go to index.ts, our main file, and at the very bottom I'm going to say app.use, and I'm going to put in a wildcard in there. That's going to say that if anything at all fails, just simply pass it into this, and that's going to be from, I'm going to say import global error handler from slash, I'm going to say middlewares and global error handlers, and right here I'm going to plug this in. So I'm going to say global error handler. So that handles the error for us. So let's try it. So right here I'm going to say, now this is where everything comes into play. So rather than throwing throwing res.error and all that stuff inside of those controllers and inside of those routes, what I'm going to do is that I'm going to say return, not return actually. We're going to say res.send, and right now I'm going to say some error occurred. So let's come here and let's just try to think of a error that we can produce. So right here, what I'm going to do is that I'm going to say if name.length is less than 2. We're going to, so now I'm not going to do any sort of res.error or something like that, but I'm going to do a throw new error, and I'm going to say a message that's just saying name should be longer than 2 characters. And let's try this. So I'm hoping that my server is running, and okay, I'm getting some errors because those values are never read. So right now, just for right now, what I'm going to do is that I'm going to prefix them with this to ignore them. So okay, we're ready for connections. So let's go ahead and try to create a new cat. Okay, so I'm just going to remove the name and I'm going to make this a post request, and let's try to create this. So you can see some error occurred, and it's coming exactly from here. Not this one, but rather this one. So now what I can do is that I'm going to say res.send, and I want to make sure that the architecture is followed. So I'm going to create a new object, and I'm going to say errors. It's going to be an array. There's going to be another thing in here, and I'm going to say message some error occurred. So that is what we're going to try now. So let's try to send it, and you will see we're following that one architecture. Now we need to make sure that this error architecture replicates across all the places, and that's where our TypeScript idea comes into play. So what I'm going to do now, just in case if you're wondering what just happened, why we're not prefixing the return, remember the next function is automatically called here. It's more like this. This one. But just for the sake of it, I'm not going to put it in here because we're going to be doing a lot of stuff. All right, so let's try to replicate a better behavior through which we can create a much more reusable error rather than throwing it like this and actually showing these things out on the play. So what I can do is that I can create a new class, and I'm going to just say errors, and I'm going to create a new class. Just for the sake of it, I'm going to call it custom error.ts, and let's call it a class. I'm going to say custom error. Right here we're going to extend error class. Now as you can see, it will require us a constructor, and also this constructor takes in a message. That's the type string, and we're going to say super message. Cool. Now that we have that, there's one more thing we need to do, is that this custom error will generally will lose the prototype of itself. So we're going to reassign the prototype of it. So I'm going to say object dot set prototype off, and this is where the prototype of this object comes into play, and I'm going to say this dot, and so it should be this, and custom error dot prototype, and that sets the prototype of this. Now one more thing is that since we're doing this, but what exactly are we trying to achieve here? So we want something that can inherit this class and then replicate the properties that are present in this. So how would you possibly go about doing that? The best possible way I can see is to create an abstract class. Now, abstract classes does not exist in JavaScript, but only TypeScript. So if you're not using TypeScript, you're using JavaScript, then it comes up to you that you should follow the architecture that we're trying to replicate here. Not exactly like just simply create an error out of this class. Because abstract, so just in case you don't know, what's the core idea about this is that we simply can do this. I'm going to say const error is equal to new custom error. That's going to throw us an error right now. Why? Because if you read it, it's going to say cannot create an instance of an abstract class. That's what an abstract class is. Now, if you are asking, well, what's the difference between a interface and an abstract class? Then, well, it's just a class and that's just an interface, nothing else. So I'm going to do an export default custom error. And right here, we also need a property that what we're going to do is that we're going to create a new property here. I'm going to say abstract. Let's just say, so if I go back to that example that I showed you, so right here you will see that we have an error type of type string, and we have errors of type this array sort of stuff. So how we're going to do that is that we're going to make sure that this is of, let's say, error type. One more thing I didn't show you is that we also have a error code. So we need to implement that. So this error code and error type both are going to come into the abstract class. So let's just go back and we're going to say error. So let's just say error code first of all, and this is going to be of type number. And let's do an error type. This is going to be of type string. So one more thing, these things do not need to be defined. That's what an abstract class is. You don't need to define them right now, but you will need to define them later. Now, we need to create this. How we're going to do that is that we're going to have an errors property that's going to have an array of these objects. How we can do that is to simply say that we will have a property or a method called serialize errors, and this is going to return, right here we're passing in a return type, something which will have a message which is going to be of type string, and also it's going to have a property. It's going to be optional, and it's also going to be of type string. This is going to be an array. So now you can see we are returning an array of these things. That's where the serialize error comes into play, and this is what the serialize error needs to return. That's what we're saying right now. So now now since this is set up, we can simply create new errors out of this. So for example, if I was to say I'll create a validation error, so I'll just simply come into errors and gonna say validation error.ts. Now what I can do here is I can say class. Now this is going to be in class. This is going to be a class, not an abstract class. So since we're not going to be inheriting this, so I'm going to say class validation error extends. Now this is going to extend our custom error. Right here, we're going to auto import that. Thanks TypeScript. Remember, auto imports only work in TypeScript. I really don't know about JavaScript. So now if you press Control space, you're going to see that following things are defined: the error code, error type, message, name, serializer, and stack itself. Because now, just in case you don't know where the stack is coming from, it's coming from this. If I go back to that custom error, we are extending error, so error actually contains a stack object. So I'm going to say error code. Now remember, this is of type number. So what I can do right here, if you want to assign it right here, no big issues, but let's just assign it right here. So I'm going to say error code, and thanks for that. And let's just say, since it's a validation error, so I'm going to say 400, because after all, that's a validation problem. And I'm going to say error type. Now remember, this is a type string. So I'm going to say validation error. So I generally like to keep it this way. It's completely up to you if you want to include this field, and if you don't want to include it, completely up to you. Now this is going to take a message, which is going to be a type string. And I'm going to call in a super. I'm going to say this dot message. So actually this dot message not, but just message. So I'm going to call it super message. That does the job for us. Now again, you need to paste in that. So you can either copy paste it or simply do that. So I can say set prototype off, and I'm going to set prototype of this of validation error dot prototype. That does the job. Now if you see, we're still getting an error, and you're going to see that the non-abstract class validation error, which is this class, does not implement the inherited abstract member serializer. So that's why we created an abstract class, because we want to make sure that no matter who creates a random error for us, we'll have to follow this very particular architecture. So now we have serializers, and remember this is what serialized error returns. So since this is a method, so let's just create this. So this right here is going to return an array of, and if you do that, it's going to come with this dot message. So I just remove that. So it's going to be this dot message. Okay, so this is still throwing us errors, and it says that instance. Oh, okay. So what we're doing wrong here is that I forgot the parentheses. There we go. So now we have the parentheses, and that's it. So what we can do more here is that since validation error probably will occur in a particular field, so I can say a property, and I can say string. Now since this property isn't going to go anywhere, so let's just make it not private. If you want to make it public, should we make it public or private? I don't know. Private maybe? Yeah, private. Okay, no issues. So now I don't need to assign that, and I'm going to say property, and again saying this, and I can say this dot property. There we go. Now that is completely working perfectly, and I'm going to say export default validation error. There we go. Now what we can do with this is that if I go back here, and if I'm checking that if name.length is less than 2, what I can do is I can say throw new validation error that we just created, and it's going to take in two things: the message, and I'm going to say that let's just say name is, or should I call it, name should be longer than 2 characters. Finally. And we also need to provide in a property, and that's going to be name itself. Let's just save it, and let's try to see what happens. If I go back to Postman, and if I try to recreate this without giving it a name, you will see, okay, one more thing I almost forgot. So right here you can see we created it, but we're not handling it anywhere. So if we are throwing in a new error, it's not going to be like taken as an error, as a default error. So what we're going to do is right here we're going to be sending this. So rather than sending that, what I'm going to do is I'm going to say if error. So right here, so let's just get our error object back. So I'm going to say that if this error is instance of, so if this error is an instance of custom error, which we need to import custom error from / and okay, we need to go one back, errors and custom errors. Now if that error is an instance of custom error, what we're going to do is that we're going to say return res.send right here, and we're going to say errors, and we're going to say error.serializer. That's going to be automatically coming for us since we have that. Now right here, if you're in TypeScript, you're going to see something like this, because not all it's going to say that not all code paths are returning a value, since same thing is not returned. So what I can do is if I do that, however, possibly that's going to mess things up if I do this. So that's what we don't want to do right now. We want to just leave it as it is for now. So let's try to make it. Let's try to run this. So I guess my server is up and running. So let's just do a yarn start. So it says that cannot find. Okay, so this is something that happens with me quite a lot. So if I'm importing place somewhere, okay, right here you can see. So you might be facing this error in one of your other projects, don't know, but it simply just puts an src there for some reason for me, which is like TypeScript never understands that. So it says that not all, okay, we are still having that error. So just for now, I'm just going to ignore it, and let's try it now. So if I go back, hoping that my server is up and running again, yeah, it's running. So let me just close it and restart it because it looks horrible right now. Okay. So if I go back to Postman, and if I try sending this error again, you're going to see now we are having that error property as we implemented. We are having a array that's passing in objects, and that is message, that the name should be longer than 2 characters, and the property is name. That's what we provided after all. Now that ends the cool part, because that's all I wanted to tell you. Now what you can do is that you can even create more errors out of this. For example, you want to create a database error, just go ahead and create it. But I would still suggest not to create too many errors, because that would be useless. try to create as less errors as possible and try to like merge them into one another. For example, if you have bad exceptions or bad errors, just simply use one error, like one error class. That's bad exception. That's it. Don't create bad email, bad password like that. That would be a horrible idea. So now there's not possibly anything that we can break in this application, right? Well, if you're thinking like that, we're possibly wrong. So let's head over to the cats controller. And I want you to go ahead and try this. In your controller, any controller you have, just simply prefix an async keyword in front of it. Just simply an async keyword, that's it. And now try to throw another exception, the exception that we were trying to throw till now. And you'll observe that the exception isn't thrown and the entire thing failed. Now here, as you can see, I'm trying to create a cat with no name. So I assume my cat controller, this should be thrown. Now I'm only saying that I assume it, in theory. So let's go ahead and try doing that. And if I do that, you will see, could not get no response. If I go back, you will see that we indeed are catching an error. You can see that name should be longer than 2 characters. That's thrown. However, that thing didn't come here. If I try sending it again, you will see, again, connection refused. Now I do guess everything broke up and nothing worked. Okay, so should I call that everything we did till now was nothing but waste? Well, no. So what's with this asynchronous errors? So let's go ahead and check something out. I want to show you this. So if we come to the error handling part or the error handling page of Expressjs, you'll actually realize that if you scroll down and here, if we see the way that they're catching errors for asynchronous functions, for example like this one, you'll realize that they are using the next keyword to throw the error inside of it. And that is what they want us to do. You want to throw an error, if it is an asynchronous error, inside of the next. Now that is certainly something we don't want to do, because if we try to do that, it will be quite a lot of pain, because you have to like entirely create something to work around this. So what we can do? Well, there is a library that can help us here. So let's head over to npmjs.com and search for Express Async Errors, and this is the first one. Make sure you open Express Async Error, not Express Async Await Errors. And here it is. All you have to do is that this simply install it and import it. That's it. Now all it simply is a wrapper around Expressjs to make that asynchronous errors a bit easier. So let's try it. Let's open our terminal and let's do a yarn add Express Async Errors. Press enter and we have that. Now let's try our server, opening our server again. And before we even try throwing errors, let's go ahead and import it. So it's a bit different as compared to the other libraries where you import something and plug it into Express. All we have to do is just simply import it, like import Express Async Errors, and that's it. And now this should start to work. Let's try it. If I go back to Postman, assuming my server is up and running, and if I try throwing it with invalid name, you will see our Express errors are being caught and properly implemented as we thought them to be. So I hope that you enjoyed this video and I hope that you learned something from it. I will see you again next time, and hope that you like this architecture of error handling and use this architecture in your applications. Thank you.